Here we go with our next lesson, least common multiples. Usual plan, we'll review our curricular outcomes before we do some relevant review of prerequisite content and get into today's main topic. So our outcome, we're going to demonstrate an understanding of factors of whole numbers by determining the, in this case, least common multiple. So how do we do this? Well, remember, a multiple of any number n is a number which is the product of n and some integer. A common multiple of two numbers is a number which is a multiple of both. The greatest common factor of two numbers is the largest number for which the two numbers can be divided with no remainder. So, getting into our least common multiple. A multiple of n is greater than or equal to n. So some of these common multiples have to be less than the others. Right? We can have multiples of 2 that never end. We can have multiples of 5 that never end. But when we look at both of their lists of multiples, there will be one number that is the lowest number on both lists. That's our least common multiple. There is no greatest common multiple. So all common multiples are themselves multiples of the least common multiple. But there's no upper limit when you're working with arithmetic, at least with all integers. In more advanced courses, especially if you're in computer science, you might see something called modular arithmetic. That can have both greatest and least values, but you can also have things like 2 times 3 equals 1. So that's the least of the strange things. Modular arithmetic, you pick a number to be modulo, and then you treat everything as the remainder dividing by that number. So if you work mod 5, well, 2 times 3, and then divided by 5 gives remainder 1, which is how 2 times 3 becomes 1. But back to least common multiples. If you only need a common multiple, not necessarily the least common multiple, you can always just multiply the two together. That is guaranteed to be a common multiple. It just may not be the lowest one possible. So one way to find the list, or to find the least common multiple of two numbers, is to just make lists of multiples and find the first number on both lists. For example, 12 and 18. Right, 12 is the smaller number. We'll start by listing its multiples. 12, 24. Well, 24 is greater than 18, so we go back to 18, 36. All right, now that's bigger than 24. We go back to multiples of 12. Oh, now we have 36 on both lists. There we go. So we'll never run out of multiples, but now we found the least common multiple. That's the lowest number on both lists. So we don't care about what the next numbers on the list are. We know our least common multiple is 36. Another way to find least common multiple is with the prime factorizations. So let's say you have two numbers and you break down the prime factorizations. This time we're looking for the highest exponents you see, not the lowest. So this time you do use numbers that appear on only one list. So for example, the least common multiple of 36 and 40. Well, 36 is 2 squared times 3 squared. 40 is 2 cubed times 5. So for the least common multiple, it's not like greatest common factor where we'd only be basing things on 2's, because 2 is on both lists. With least common multiple, you use everything. So you're going to have a 2 and a 3 and a 5. Now, the highest exponent of 2 is the number 3. So that's the exponent we use. Highest and only exponent of 3 is 2. And the highest and only exponent of 5, when it's not visible, the 1 is implied. So 2 cubed times 3 squared times 5 will give us our least common multiple. In this case, 360, which is 10 times 36 and 9 times 40. We can also say the product of two numbers is the product of their greatest common factor and least common multiple. So we can see that now with the way we did prime factorizations. If greatest common factor uses the lowest and the least common multiple uses the highest, every single one of those factors is accounted for when you multiply the two together. It's going to be the same as m times n. Regardless, if you already have the greatest common factor, getting the least common multiple is now relatively easy. We take the least common multiple, or to find the least common multiple, we take our two numbers, multiply them together, divide by the greatest common factor. You can even simplify the math by doing the division first, since each of those numbers is evenly divisible by the greatest common factor. Otherwise, it would not be the greatest common factor. So with the example we had before, with 36 and 40, the greatest common factor is 4. You take 36 times 40, divide it by 4, you get 360. If you divide by 4 in advance, that's either 9 times 40 or 36 times 10. So, again, calculators can do this, but again, emphasizing strongly when you're dealing with calculators. These should be used to improve efficiency, not to replace thought. Don't depend on the calculator until you're already at the point where you can do things by hand. All right, so on the TI, you hit your math button, the number category, and option 8. That's our least common multiple. We then enter up to 2 numbers at most with commas between them. If you have 3 or more numbers, do the first 2, and then the answer with the next, and then the answer with the next, and so forth. On the Casios, you can enter more than 2 numbers at a time. So if you have 5 numbers, just put 4 commas between the 5 numbers. So that's option, F6 number, F6 to go to the next page of results and pick your LCM. You, again, enter all the numbers with commas between them. So, doing examples. To find the least common multiple of 36 and 60, we have a few approaches. If we do prime factorizations, 36 is 2 squared times 3 squared. 60 is 2 squared times 3 times 5. Least common multiple is the highest exponent of each, so that'll be 2 squared times 3 squared times 5. And that's 180. Example 2, least common multiple of 49 and 35. So again, 49 is 7 squared. 35 is 5 times 7. So the highest exponent we see of 5 is 1. Highest exponent we see of 7 is 2. So 5 times 7 squared will be 5 times 49, or 245. The local Sobeys sells frozen hamburger patties in packs of 6 and hamburger buns in packs of 8. How many of each will you need to buy to make sure there is a bun for every patty, and vice versa? This has actually changed a little bit since I made this question. Sobeys is now selling hamburger patties in packs of 4. Regardless, how many of each will we need to buy? Well, we don't have to worry about wasting food here. Assume you are inviting enough people over for a party that they will all be eaten. So, large number of people, or my brother-in-law. So the least common multiple of 6 and 8 is 24. So you'll make sure you have 24 of each. So that's 4 boxes of patties and 3 bags of hamburger buns. Each will then make 24. So let's do some exercises here. We want to find the least common multiple of 12 and 15. Sorry, I should have paused a little bit longer there. That is 60. Exercise 2, least common multiple of 24 and 30. Pause now, take the time you need. Their least common multiple is 120. Now, 27 and 37. Pause now, take the time you need. Little hint, 37 is prime. Their least common multiple is 37 times 27, which is 999. All right, in summary, the least common multiple of two numbers is the smallest number divisible by both of them. There's multiple ways to find them, either with or without technology. Without technology, if the numbers are too large to recognize the prime factors, so for example, these 8-digit numbers here, or the 7-digit numbers, it's best to find the greatest common factor with the Euclidean algorithm, which we covered when we talked about greatest common factors, and then use our trick where we divide and then multiply. So, and just for the record, this was generated by looking up lists of prime numbers in the thousands, so you really wouldn't have any practical way to find the least common multiple aside from these techniques. Greatest common factor is 3,167. So then when we divide, or when we find the least common multiple, then it is 33,426,947,089. If you have any questions or feedback, please leave them in the comments, and I will try to respond in a timely fashion. You probably could have guessed from our curricular outcomes, our next couple lessons will be talking about square roots and cube roots.